So we start with the next episode of Train, which is the Rajdhani Express. Now, this episode will help us understand Type 3 of train. What is Type 3? Two trains are traveling, and both the trains are traveling in the same direction. So, what is happening now? This is a Rajdhani Express. This is traveling behind this local train. The question is, this train is crossing this train completely. Okay, and there is a question that is being asked to us. So what is happening now? For the first time, train is crossing an object which is not a stationary object. This train, Rajdhani Express, is crossing this local train, but this local train is not standing at its place, it's moving. So train is crossing another train when both are moving. Earlier we saw type 1, in which train was crossing a tree, but the tree was stationary. Train crossing an object having negligible length. Then we saw train crossing a bridge, an object having some length, but both were stationary. Tree and bridge were stationary. In this case, train is crossing another train and both of them are moving, and that is when the concept called as a relative speed come into the picture, because this Rajdhani Express is crossing this train, but this train, local train, is also moving. It is not a stationary object. If this was a bridge, then it was easy, right? It would have crossed this and then it would have crossed this length. Distance what would be just like the previous type 2, length of the train plus length of the bridge. But then the thing here is it is moving, and that's where relative speeds comes into the picture. Now let's start what is being said to us. Rajdhani Express crosses the Mumbai local train in 20 seconds. Now first of all, let us understand what is this 20 seconds. The 20 seconds, when do I start the stopwatch and when will I stop the stopwatch? So say Rajdhani Express is here, stopwatch is not started. Rajdhani Express comes here, not started. Rajdhani Express comes here, and the distance between the two train is 0. This is the important part of type 3. The distance between the Rajdhani and the local train is 0, which means the last bogie of the local train is just touching the engine of the Rajdhani, and that is when I start with the stopwatch. What is happening? This Rajdhani crosses this local train. Yes, will I stop the stopwatch now? No, it will cross its length as well. It will cross its length as well, and now I'll stop the stopwatch. So what is the distance traveled in this case? If you can see, I start the stopwatch now. Distance traveled is length of the local train plus length of the Rajdhani, right? And this time taken is nothing but 20 seconds. When Rajdhani crosses the length of the local train plus its length, that's it, that is 20 seconds. So I'll write it here. Time is equals to what? Distance upon speed. Time is given to me as 20 seconds. In this 20 seconds, distance travel, as I just rightly pointed out, this is the length of Rajdhani plus length of the local train divided by the speed. But both of them are moving right now, and that is where relative speeds comes into the picture. So let's see what is given to me in the problem. Rajdhani Express crosses the Mumbai local train in 20 seconds. I know now what is the distance travel in that. The speed of the faster train is 72 km per hour. So the speed of Rajdhani is given to me as 72 km per hour. And the speed of the slower train is 27 km per hour. So this is given to me as 27 km per hour. Speed of the local train. The length of the faster train is 100 meter. Which is your faster train? Rajdhani. So this is given to me as 100 meter. Then find the length of the slower train, which means this L. Speed. The length of the local train is asked to me if they are moving in the same direction. I know that they are moving in the same direction. So now imagine if they are here, distance between them is 0. What will you do with the speed? Speed of one is 72 and the speed of another is 27. So what will happen in 1 hour? Imagine what will happen in 1 hour. This train, local train, will move ahead by what? 27 kilometers. Correct, because the speed of this train is 27 km per hour, and this Rajdhani will move by what? 72. Will move by what? 72. But then this Rajdhani got ahead of local train by what? By how many kilometers did it got ahead of this? It got ahead by 72 minus 27. You will say, how is this happening? Because if there was no local train here, and it just has to cross a barrier, which has a length of say L. L is nothing but length of the local train. Then it would have just crossed this barrier, because with the speed of 72 it will go in 1 hour 72. But what is happening, if this goes ahead by 72, this is also going ahead by 27. So as a resultant, this goes ahead, if this is just chasing this goes ahead only by what, 72 minus 27, because if this went ahead by 72, this also went ahead by 27. So resultant, what did it go ahead? 72 minus 27, because this thing needs to completely cross this thing, correct? And that's why you subtract the speed when two trains are traveling in same direction. If you need one more example in the easiest possible way, let's draw two trains here. So say speed of this train is 60 meter per second and speed of this train is 50 meter per second. Now what will happen in 1 second? Imagine this train will move by what? 50 meters. This train will move by 50 meters and this train will move by what? 60 meters. So as a resultant, how much did this train, second train, faster train, move ahead of the second train, which is nothing but 60 minus 50, correct? Because if this train is moving ahead by 50, this train is moving ahead by 50, this train is moving ahead by 60. So as a resultant, it went ahead of this train only by 10 meters. Because if this is going by 60, this is also going by 50. So if this is chasing this, it went resultant ahead only by 10 meters. So that's why you subtract the speed when two trains are traveling in the same direction. So subtract the speed. I'll subtract the speed as what now? 72 minus 27. 72 minus 27. And that's it. Now I get to my answer. This is 20. This is 100. This is plus L, length of the local train. 27 minus 72 is nothing but 45. But the problem here is this is seconds time, distance is in meter, but the speed is in kilometer per hour. I need to convert this to meter per second, because 72 and 27 are in kilometers. So what will I multiply this by? 5 by 18, because I need to convert this. So now this is how the problem turns out to be. 20 into 45 into 5 by 18 is equals to L plus 100, and I need to find out what is L. So just cut this now. 9 2s are 18, 9 5s are 45, 2 1s are 2 10s are 5 into 5 25 into 10 is nothing but 250. 250 minus 100 is nothing but L. So L comes out to be what? 150 meter, and that is the length of the local train. That is the length of the local train, and that is what I was supposed to find out. So what did we learn from type 3? If two trains are traveling in the same direction, what do you do with the distance? Distance is nothing but the length of the two trains. And what do you do with the speed? You subtract the speed. Why? Because if first train is moving, second train is also moving. But second train needs to chase first train, right? But if it is moving, this is also moving. So resultant, this is moving, is nothing but the subtraction of the two. And that's why you subtract the speed. So no type 3. This will help you to solve a lot of problem of trains when trains are moving in the same direction and the distance between them is 0.